This first one you're going to want to pay attention to, because especially if you kind of started understanding yesterday, this will offer some type of a juxtaposition so that you can compare and contrast. Mainly, what would the first step be here on this one? Good, distributed -1. So Elsie is kind of scratching her head right now because she multiplies by -1 and she says, hey, Mr. Romero, didn't you say yesterday that when you multiply by a negative, the sign flips? So why did you leave the sign facing the same direction? Well, if you must know, Elsie, what I said was if you multiply or divide, either one for that matter, by a negative on both sides. Were both sides multiplied by a negative here? No, it was only the left side. And that negative was already there. I'm not the one, I mean, I guess I did it because I'm working out the inequality, but I didn't manually multiply both sides by a negative, so the inequality stays as is. Next step. Próximo paso, por favor. Gracias, muy amable. Next step. No, you could, but I like to combine my terms because that's what they do in the hood. The last time I was there, I saw these kids combining like terms. Next step. Good, -18. -18. So -9c is greater than negative. Oh, Ohio.
Oh wait, you have to.
What do we do last? Divide by -9 where? Oh, so what's going to happen? I'm going to flip the script. I have my C, but now it's going the other way. I'm going to 2. Besides solving, we also learn how to provide a graphical representation of all of our solutions. Right, Jono? So what's my critical point? 2, open or closed? It is going to be open. And then Amid C, left or right? 50-50. I gave you 2 choices. Izquierda o derecha. Shush! Emil C. No sé. Correcto. Well, left or right? Any questions? All right, you do the next one. Solve for X. You can do it. I believe in you, Taiwan. Rip his freaking head off. You can do it.
I know the answer.
You said you didn't say.
Everybody can do it. I believe in all of you equally, except for Hope. Esperanza. Is bad mood today? What's your emoji for the day? You're sleepy? Somebody said they got it. You got it, Jason. What'd you get? Well, definitely not equals.
I mean, X. Oh no, X.
Close. Greater than or equal to yes. So, as far as how you read it, like Jason just read it to me, so the way it reads will depend on what side of the inequality sign the X ends up on. In this case, I prefer to move the x's to the right because then I'll end up with a positive in front, but you don't have to. Well, watch. If I move the x's right, I have to kick out the 4. So 6 minus 4 is 2, less than or equal to 2x. Divide by 2, divide by 2. So 1 less than or equal to x. But wait, Mr. Romero, I was listening intently to what Jason says. I hung on his every word. And that's not what he said. Well, watch. What's the critical point here? 1, just like Jason's was. What type of a point? Closed, just like Jason's was. And then finally left or right. To the right, mouth eat variable, we shade right. So that's another nice thing about graphing, because if I write down what Jason said that x was greater than or equal to 1. Whether you write it my way or his way, the graph would still be identical. It's the same graph. Just do this for Valentine's Day. It's a heart. Yeah, you go on. You could do it that way too, yeah.
There you go.
Who started that?
I don't know, you gotta ask Xavier. Alright, we'll do these last two together. Oh, she wanted to know who you were throwing the heart up to. First step. Jocelyn, primer paso, por favor. Go, distribute. 9 plus 2x less than 7 plus 2x minus 6. And then? We are going to combine like terms, so 9 plus 2x less than, you can either write 1 plus 2x or 2x plus 1, either one works. Well, something is getting a little fishy. It's a little fishy. So, yeah, see, I'm trying to isolate the x's, but when I do so, they all cancel. So before you jump to conclusions, yeah, we're going to take what we know from equations, but we can't take it literally because you might jump to conclusions. So just like with equations, we learn to drop the leftovers as if they were hot. But before you be like, oh, look, those numbers are different, so there must be no solution. Wait. Read what's left over. What's left over says that 9 is less than 1. Is that I got the 1 from 7 minus 6. Is 9 less than 1? No. So what that's telling you is that no matter what number you plug in for x, your inequality will be what's known as inconsistent. It won't work. So this inequality has no solution. But wait, Mr. Romero, don't we have to also graph all? Yes, there is no number that will make that true. No real number. But wait, don't we have to graph it? Yeah, you were asked to graph, but think about it. If you were to try to graph no solution, if shading means solution, and you're trying to graph no solution, what are you going to graph? Nothing, yeah. So, yeah, these you don't have to graph. If there's no solution, you don't have to graph. If Emma asks, Emma gets. Well, if she can figure out how to bend the space-time continuum, then yes.
I will figure it out.
Okay, distribute again, and we'll do this one together.
6w plus 1.
No more simplification can be done, but then now Dario's scratching his head. He's like, no entiendo, because when I try to when you try to isolate the W's, they again cancel out. But in my experience, you really love math, don't you?
Yeah, yeah.
He's gonna make math fun again. So in my experience, in my experience, what happens here is that people see that the numbers are different, and again, they're too quick to be like, "Yeah, got it, no solution." But read what it says. Right here, the statement says that -4 is less than or equal to 12. Is that true? Yes, -4 is less than 12. But wait, it's not equal to. It doesn't have to be equal to. That's why it says less than or equal to. It's one or the other. So because this is true, this is the opposite of no solution. It's all real numbers. That means every single number that I put in for W will make that inequality true. Well, wait, Mr. Romero, do we have to graph that? Well, this one, yeah, you actually could graph. But if I were to graph every single real number, what would the graph look like? What would you shade? Well, you would shade the entire number line, and there's obviously no need to do that. That's you're not gaining anything. So you don't have to graph these either. So instead of covering compound inequalities, what I decided to do for these last 10 minutes, especially since I know that you've gotten a head start on the assignment. No. I'm going to do a couple of the ones from the inequality work. Since I don't have a lesson on inequality word problems, let's apply what we know here. And you have plenty of space on those papers to write this down. No, you did this one. What? Hold on. Oh. All right, here we go. So let's write some of these down since I don't have a lesson on word problems for inequalities. Let's just do a few of these examples. Tomorrow we'll have the cards here, or maybe not. Maybe I can just come up with another lesson. You can talk for another hour. You have $20 to spend on taxi fare. The ride costs $5 plus. Back in the days of the cavemen before Uber, we had to write taxi cabs, and this is $5 plus $2.50 per kilometer. Write an inequality to determine the distance. So look, they've defined the variable for us. We're looking for a distance that you can ride for $20. Okay, so let's go. What does the ride cost? Look for keywords. What does it cost? Do I need to make it bigger? You can't see it?
Yeah, I really can.
No, you don't need it.
I don't have my glasses. Oh, yeah.
What does the ride cost?
Right across $5.
Okay, it does cost $5, but it also says plus $2.50 per. There's another keyword. $2.50, but for the $2.50, I don't have to write $2.50. I can write 2.5 per kilometer, but they've told you that we're going to call the kilometers D. And we want that ride to be able, I need to be able to ride for $20. If the ride ends up costing more than $20, will I be able to pay for it?
No.
No. If it costs exactly $20, can I pay for it? Yes. If it costs less than $20, can I pay for it? So there's going to be a less than or equal to sign 20. That's the first thing they want me to do. Guys, at this point, you just look. If you don't want to listen, fine, but just be quiet, because I don't want to talk over you. 5 plus. You can write. You should be able to write 2.50, but 2.5 is the same thing. D less than or equal. And if you've done Khan Academy before, you know that they have a limited amount of problems. So if you actually write these down, you might get the exact same ones, and I might just be doing your work for you. So what is the maximum distance that you can ride? Well, yeah, now we got to solve. They want it in kilometers. Let's see. So -5 minus 5, 2.5 times the distance less than or equal to 15, divided by 2.5.
Oh, so they want to show them the equations.
Yeah, you have to write the full inequality and then solve it. What's 15 divided by 2.5? Is it 6? Opie copy? No telephone?
You can check them.
That's what it is. So 6 kilometers. Yeah.
Yeah, you got it. Good job.
Boom goes the dynamite. All right. Yeah, it's a lot of work, but luckily we're excellent readers.
Well, no.
Tom is the deli manager at a grocery. This will be the last one that we can. Xavier, be less cool, man. Just try. You have enough cool to go around. Just sit like the rest of the boys and girls. Tom is the deli manager at a grocery store. He needs to schedule employees to staff the deli department for no more. Hey, look. There's one thing. Remember when I gave you the list of all the words for equations? We didn't get into inequality words, but no more than is an inequality word. If something is not more than, what can it be? It could be less than, but it could also be. Yeah, so this looks like I'm going to end up using a less than or equal to sign, and so something has to be less than or equal to 260. But let's read. They've again defined the variable. They want n to be the number of full-time employees, and we want to know how many he could schedule. So Tom has one part-time employee who works 20 person hours per week, and then each full-time employee works 40 hours per week. And we want just number of full-time employees. All right, well, since we know that he only has one part-time employee, how many person hours are coming from part-time employees? If you only have one. If there's one person working 20 person hours, how many person hours are coming from part-time employees? Dave, you know that I haven't given, this is my first year at Parkview and I haven't given it attention yet. I think you might be the first one. I'll make a photocopy of it and you can take it home and put it up on your wall. Mr. Romero's first ever Parkview detention.
You should put it on your wall.
I can do that too.
Make it different.
I sure would like to finish. One person working 20 hours. How many hours is going to come from that one person? 20. Plus, how many full-time is 40 hours, and then n is the number of people. So now just solve -20 minus 20, 40n less than or equal to 240 divided by 40. And remember, here we're counting people, so if you get a decimal, either you're going to be like a really short person or you're doing something wrong. So less than or equal to 6. Hold on. Yeah, again, we have to write, was it 6 last time? Write the inequality. So 20 plus 4n less than or equal to 260. And now when I graph this, what's my critical point? 6 open or closed? Closed, but if I wanted it open, I can click it open. And then what direction am I shading?
Left.
Left, so I have to switch the direction. Uh-oh. What did I, Alright, I'll fix it and put it on the video.
Okay.
Divided by 40. What did I put? Oh, that's why 40. Okay, thank you. That's why. There's a typo. There it is. Alright.